Okay, so I want to talk a little bit about what happens if you don't have 0 over 0, right? What happens if you have some other number over 0? And again, just to kind of remind you that, 0 over 0, that's usually indicative, like almost like always, indicative that there's a hole, right? So 0 over 0, there's a hole. And remember, a hole is removable. We can deal with that. But now the question is, what happens if all of a sudden we have some other number like 1 over 0, right? What does that mean in terms of our answer? Well, 1 over 0 or 2 over 0, really any other number over 0, really indicates that there's no longer a hole, but there's an asymptote, okay? And the thing about an asymptote, that's non-removable. And the behavior of an asymptote could lead to one of three different answers, depending on, again, what is the function doing on either side of the asymptote. So, like, for example, one possible outcome for a limit is that if your asymptote, here we go, let's say it's like right there, at x equals some constant c, and let's say our graph looks something like this. We're coming along here, and it goes up like that, and then perhaps it's something like this, okay? So as we approach the asymptote, the left side is increasing without bound, and the right side is decreasing without bound. So we could say that the limit as x approaches c from the left side of f of x, okay, so from the left, it's increasing without bound, which we'd say is infinity. The limit as x approaches c from the right side is equal to negative infinity. And so infinity and negative infinity don't match. So if the behavior of the asymptote is one up, one down, we would say and conclude that the overall behavior, I guess I can use this color, we could say that the limit as x approaches c, oops, jump too far. Almost. Aha. Limit as x approaches c of f of x from both sides does not exist, okay? Now, does not exist is different than infinity or negative infinity, okay? Does not exist and infinity and negative infinity, I get it, they're all not numbers, but infinity and negative infinity at least give behavior, right? At least it gives direction. It describes the function's behavior, and that's what a limit does. Does not exist means that the left side's not behaving like the right side. Okay. Now, what other kind of behavior could you have at an asymptote? Well, so if we draw in another graph that has a vertical asymptote, I'll use red again, just to be consistent. Okay, so now, what if our function does this? So we're increasing on that side, and then we also came from that side, right? So in other words, both the left and the right side are going up towards infinity at x equals c. Well, if the left side matches the right side, even though we don't have a numeric value, we could still say that the limit as x approaches c of f of x from both sides is equal to infinity. And again, this value of infinity, at least it's describing the behavior, right? At least it's telling something about this particular function. Excellent. Okay. Now, and then you could probably see where our last possible behavior at an asymptote is. Instead of both trending up towards infinity, we could say they're both trending down towards negative infinity. So that maybe your function does something like this, and that's where it came from over here. And so again, if this is c, if this is the value x equals c, then we could say the limit, oops, my bad. We could say that the limit as x approaches c from both sides of our function equals negative infinity. Okay, so three different kinds of behavior. And again, how do you know that's not a hole? That's the biggest question I think that a lot of students ask initially. How do you know it's not a hole? Well, it's based on, do you get 0 over 0 or another number over 0? Because if it's not 0 over 0, right, if it's not this, then it's an asymptote. And you could look at an example, and we'll just do two here. So if I look at this problem here, it says let x be -4 from the right. Well, the thing is that if I let x be -4, eventually that denominator is going to be a 0, right? If I try to direct substitute that in, and -4 minus 3 is -7. So this value is not 0 over 0, right? It's still not defined, right? But it's not 0 over 0, so it's not a whole. This then means that there's an asymptote. And if there's an asymptote, it's non-removable. So what I like to do here is I just even like to just sketch out a graph. I just like to say, okay, where is the asymptote located? At -4. So then I draw an asymptote at -4. So x equals -4. And then I start to analyze the behavior to the right of -4. So pick numbers that are to the right of -4. So if you pick numbers that are to the right of -4, you're picking this side, right? These are the numbers that are to the right of -4. So we're looking at the behavior on that side of the asymptote only. So numbers that are to the right of -4, like -3 or -3.5, right? -2, anything over here. So if you were to evaluate, let's say, f of x, so let's say f of like -3.5, right, which is like, over here somewhere. Well, that puts -6.5 in the numerator, and then -3.5 plus 4 is 0.5. So you've got a negative number divided by a positive number. This actually becomes -13, by the way. So so at -3.5, we're at -13. We're down there. And the thing is that the closer you pick to -4, like let's say you pick -3.9. So -3.9 means that that's -6.9, and then -3.9 plus plus 4 is 0.1, and so then -6.9 divided by 0.1 is actually -69, which is even further down here, and so our function is trending down. Well, that describes the behavior, right? So what is the limit? The limit is equal to -infinity. And I only had to analyze the right side because it just said analyze the right side. Okay. And you could see example B as well, and we'll finish the video with example B, that if you have, again, approaching -1 just from the left this time. So -1 would be our asymptote. X equals -1, and we're looking for things to the left, so we're looking at values over here. So pick something that's to the left of -1, like -1.1, right? -1.2. Even -2 could get you started, if you don't want to deal with the fractions. So if you put in -2, so a -2, so if I try to find f of -2, so -2 is 2, and then -2 plus 1, -1. So then we get -2. So at -2, I'm at -2. So I'm already kind of lower than the x-axis. It looks like I could be -infinity. If you evaluate f of, let's say, -1.1, if you get really close, so that becomes a positive 1.1 in the numerator, and then it becomes a -0.1 in the denominator. That's -11. So the closer I get to -1 on the left, the lower I get. So my function clearly is now decreasing without bound. So it just happens also, coincidentally, that it's -infinity. Okay, so the key, I have to stress this, the key, is it 0 over 0, or is it any other number over 0? If it's 0 over 0, you are a whole. If it's any other number over 0, then you are the asymptote. Okay, very nice.